All right, let's jump right in. Today we're going to demystify a concept that's, well, fundamental to pretty much all modern software, object-oriented programming, or OOP for short. We're going to break down exactly how coders take a simple idea, a blueprint, and turn it into a real, working piece of software. So first things first, let's build our foundation. And you know what? We're not even going to look at a single line of code just yet. Nope. We're going to start with a really simple, powerful idea that anybody can get their head around, and it's really the core of this whole thing. So let's do a little thought experiment. Just imagine for a second that you are talking to someone who has never, and I mean never, seen or even heard of a dog before. How in the world would you describe one? What are the essential things you'd have to tell them? Well, you'd probably start with its features, right? You'd talk about things like its breed, its weight, maybe its color. And then you describe what it does, its actions. It barks, it runs, it wags its tail. And boom, right there, without even realizing it, you've created a conceptual blueprint. Just hang on to that idea of features and actions. Okay, so we've got this blueprint idea. But a list of actions on a piece of paper is one thing. How do we actually teach our code to do those things? How do we give it the power to perform an action? Well, this is where we bring in our first official coding term, a method. Really, just think of a method as the programming version of an action. It's a neat little block of code that handles one specific behavior, like barking or running. It's basically the verb in our coding sentence. And here's the thing about methods. They're very structured. To build one, you need these four specific parts. You've got the return type, which is just what kind of information it gives back. The name, of course, so we know what it is. The parentheses, which hold any info it needs to do its job. And finally, the method body. Inside those curly braces, that's where all the action actually happens. Now, this is super important. A method won't do anything just by existing. You have to actively call it or invoke it to get it to run. When you do that, your main program kind of pauses, hands over the controls to the method, lets it do its thing, and then takes the controls back once it's finished. Now, a quick but really important side note on methods. Sometimes you need to convert data from one type to another. We call this typecasting. Sometimes it's totally safe. We call that implicit. It's like pouring water from a small cup into a big bucket. No problem. But other times it's explicit, and that can be risky. It's like trying to pour that whole big bucket into the tiny cup. You're going to lose some water. And in coding, that's called information loss. Definitely something to watch out for. All right, so now we get it. We've got our features and we've got our actions, which we now know are called methods. So let's see how we bundle all of that together into the master template. And that master template has a name. It's called a class. This is it. This is the big idea. A class is the blueprint. It's not the actual dog itself. It's the detailed design document that describes what any dog we create will look like and be able to do. And what goes into that class blueprint? Well, it's just two key things that we're already totally familiar with. First, the attributes. Those are the features, the data, the nouns. And second, the behaviors. Those are the methods we just talked about, the actions, the verbs. That's the whole shebang. Okay, this is the magic moment. This is where it all clicks. We've designed our blueprint, we've got our class. Now it's time to actually build something with it. It's time to go from an abstract plan to a concrete, usable thing. And that actual thing is called an object. An object is a real, living, breathing instance of a class. So if our dog class is the blueprint, an object is your specific dog, Fido, sitting right there on the rug. It's the real deal, built from that plan. So let's look at our dog blueprint one more time, but now with our new vocabulary. We've got our attributes, like breed and weight, and we've got our behaviors, which are our methods, like bark and run. This is the complete design all laid out. And now, for the grand reveal. This is what that idea, that blueprint, actually looks like in code. See it right there? Public class dog. And inside you can see an attribute, string name, and you can see a behavior, void bark. It's a direct one-to-one translation from our idea right into the code. Pretty cool, huh? And this, right here, is where the true power of OOP comes into play. You only have to write that dog class blueprint once. Just once. But from that single blueprint, you can create thousands, even millions of unique dog objects. One object might be a German Shepherd named Rex, while another is a poodle named Coco. Same blueprint, totally different details. Okay, let's wrap this up and bring it all home with a quick summary and a little challenge to really make this knowledge stick. Seriously, if you only remember one thing from all of this, let it be this right here. A class is the blueprint. An object is the actual thing built from that blueprint. That simple idea is the absolute heart and soul of object-oriented programming. And hey, if you're feeling ready to take the next step, here's a little challenge for you. Go do a quick search and find out about the behavior of something called vargs. It's directly related to what we talked about with methods, and it's a perfect topic to explore on your own. And that's our look at the basics of OOP. If this helped things click into place for you, do me a favor and hit that like button, share this with anyone else who might find it useful, and of course, subscribe to Tech Talk 101 so you don't miss our next explainer. Thanks so much for watching.